Howdy, PreCal. It's Miss Kosh. Let me tell you how this is going to go. We took a worksheet and a set of notes or whatever that I have used in the past and tweaked it to fit our style a little bit better for this year because of the distance learning and all that kind of stuff. So I already had this lovely answer key. Okay, so my answer key was glorious, it was wonderful, and I just don't have time to redo it. So what we did with this work is we split part of it to be notes and part of it to be practice. So in this file, this is my notes file. I already have a video for the first page. I hope you've already seen it. I made that for something else. Anyway, it's good. It's great. Go watch that. Hopefully you've already seen it because I'm going to post this video second. Now what I want to do is I want to work through these two problems here on the notes. No, these 1, 2, 3. Those two problems on the notes, and then what you'll do for the practice, if I come back here, what I did for my answer key, that looks lovely, but I went through, this is your new homework assignment, but each problem on the homework assignment came from my old worksheet. So my answer key for this year shows you where they came from in the past. Okay, so I'm kind of linking like this one, this number 1 was actually now going to be part of the notes. Number 2 is the new number 1 and that sort of thing. So I'm sorry, in a perfect world, I'd redo it. It is so far from a perfect world, it's not even funny. Okay, that being said, let me talk through this problem. Unfortunately, it's a little hard to see on your version. Well, you can't see on your version what that says. There was a text box or whatever right here, and so not a text box, an image, and so it covered up part of the equation, but that's what it's supposed to say. So let's describe what's happening here. The first thing I want to point out to you is that this f of x really we need to factor out this negative. If you don't factor out the negative, you're going to get your shifts wrong, and so that becomes a problem. So this is 2 raised to the negative, and then this becomes x plus 3, and then we have a plus 4. Okay, so the negative in the exponent reflects us over the y-axis. Okay, and so did you notice I kind of hesitated before I said anything? So hang on, I'm going to write it down. Reflected over the y-axis. Sometimes I forget, okay? And so what I would do is I would then say, wait just a second, okay, which one of these changes, if that's my parent function, which one of these, a negative 2 raised to the x or y equals a 2 to the negative x, which one of these changes my making it from a growth to a decay, and which one of these reflects it over the x-axis, therefore changing my range? What I notice here is that this one right here could be written as 2 to the 1 over x. Is this helpful for you? So in other words, if this x had been, well, it's now, no. Okay, I'm sorry. Let me say this. I just figured out this is 2 to the x raised to the negative 1. Okay, so 2 to the x to the negative 1 would be the same thing as saying 2 to the negative 1 to the x. Well, 2 to the negative 1 is 1/2, and so this is now 1/2 to the x. This is a growth. That was the parent function was a growth, and this is now a decay because that a value, or the a to this value is less than 1. That's why it's decay. So and then this also, so that's one way, if I forget which I obviously did, what my reflections do, which negative gives me which reflection, that's what I like to think about. Delete. The other thing on this one right here is that this is going to change I now have all sorts of negative y values. So this piece alone only gives me positive numbers, but then when I throw this negative out front, it's now going to, instead of being, okay, it should go through here. And now instead of being this, it's now reflected down like that. And I have made an absolute mess. Okay, here we go, delete. So looking at this one, it's been reflected over the y-axis. So now this tells us that it's going to be a decay, and it's and we kind of work off of that. Okay. Then we also know that this was shifted left 3 and up 2. I lied, up 4. Okay, so if you think about our parent function normally does something like this, but we reflected it because of the negative, so it's now doing something like this. And now we've taken this and we're going to shift it to the left 3. So this pivot point is going to go to the left 3. 1, 2, 3. Oh, I shouldn't make a big dot. Left 3 and up 4. 1, 2, 3, 4. So that's my new pivot point, okay? My new pivot point is at the point -3, +5. Now, sometimes it gets a little hard to see what's happening on the graph, and I'm going to get rid of a lot of this mess because I don't need it. But the other way to think about the pivot point is, what do I need to plug into my x so that my exponent becomes 0? Well, if I plug in -3, okay, so if I say f of -3, this becomes 2 to the -3 plus 3 plus 4. Well, this, right, oh, I bumped that with too much, anyway, it's fine. This becomes 0, and so now I have anything to the 0 power is 1. This is equal to 1 plus 4, which is indeed 5. Okay, that's another way. So that might be easier than counting little spots on the graph. But I wanted to show you both options just to show you, see how they make sense. Okay, so there's our pivot point. We know that its asymptote had been, the parent function has an asymptote, of y equals 0. But we just shifted everything up 4. So we now have an asymptote of y equals 4. We'll talk about in behavior in a second. The domain of my brain just stopped. The domain of a exponential function is all reals. You can raise that. You can put anything in for the exponent. The range, however, is not. The range it approaches that asymptote, but it never gets there. So it's from 4 to infinity. And this one is going to be, so here's that asymptote of y equals 4. And now we're doing something, this was a decay situation, I still missed the point. Let's make the point bigger. Okay, it's going to do something like that. So now I can see what my end behavior is, and my end behavior is as x goes to infinity, my y value is going to get closer and closer to 4. As x goes to negative infinity, my y value is going to go to positive infinity. All right, so now the next part comes along. They want us to find the inverse. So the first thing I'm going to do is I'm going to switch my x and y. So x is equal to 2 to the negative. You know what? Let's keep it factored out. Y plus 3 plus 4. I'm going to start solving, and I have x plus 4 is equal to 2 to the negative y plus 3. Or if I were to write it this way, 2 to the negative y plus 3 is equal to x plus 4. Now I can think of this in logarithmic form. And so here is my base. That 2 is my base. So I have log base 2 of, okay, hang on, 2 to the, I just forgot, okay. Do you agree with this? Let's do the I heart logs. 2 to the this equals that. Is that what I have there? It sure is. We are looking good. Okay, so I need to solve for y. I'm almost there. And I need to divide by the negative and then subtract the 3. So I can say that the inverse of f is equal to a negative log base 2 of x plus 4. And then I took care of the negative by dividing both sides by negative, and then now minus 3. Okay, so here we go. What this has done, and so now we want to describe, we can look at the transformations here. On this one, we reflected over the x-axis. A minute ago, we reflected over the y-axis. And keep in mind that if these are inverses, then whatever I do to the parent function, like whatever I do to x in the parent function, I'm going to do to y in the inverse. So whatever I do to y in the parent function, I'm going to do to x in the inverse. So a minute ago, we reflected over the x-axis. Now we reflect, I lied. A minute ago, we reflected over the y. Now we reflect over the x. Another way, so the way that I think about this, hang on. if I can't remember, I need blank space. Give me blank space. Okay. If I have y equals log of x, that looks something like it goes through like this. If I can't remember what happens between these, then what I think about is which one of these changes my domain. So keep in mind the domain here goes from 0 to infinity. Well, over here, if I can't take the log of a negative, so I can only plug in negative x's so that a negative negative becomes a positive. Oh my goodness, what is happening? So this one is here, and it's going to do something like this. This changes my domain to be from negative infinity to 0. This one, however, so this would reflect over the y-axis. And these rules are always the same, but sometimes I forget. And so this is just how I think through it when I forget. This one's going to reflect over the x-axis, and so it's going to do something more like that. Okay, coming back. There's a lot of mess. I'm so sorry. In a perfect world, it's not a perfect world. Okay, so we reflect over the x-axis, and then we have to consider the fact that we're going to go left 4 and down 3. Wait a minute. Oh! Wait, I messed up somewhere. I'm so sorry. Hang on, let's see if I can catch it. Oh, okay, did you find it? Pause the video. You find my mistake, okay? You find it, because I'm about to tell you what it is, but let's see if you can find it. Okay, you back? Did you find it? Here was my mistake. I had this plus 4 right here, and I made it, I added 4. Well, it's almost lunchtime. Let's see how far I can get. So this should have been a minus right here. That should be, there we go. So that was my mistake. So instead of left 4, instead of left 4, I needed to say I'm going to go right 4. And here's how I caught that mistake. What happens here, I went in the positive direction for my y value, so I need to go in the positive 4 in my x value in its inverse. This one I went in the negative, I went left 3, that's kind of going in the negative direction, and so this was down, that's also like in the negative. So I went in the negative direction for x should correspond to the negative direction for y in its inverse, and so that helped me catch my mistake. So really, we could say I did this on purpose. I didn't, but we could pretend. But this is how I'm going to catch my mistakes. All right, so I'm going to get rid of this because there's too much clutter. And so now let's graph this. I've gone to the right. Okay, I reflected over the x-axis. So my initial, so here's that pivot point. I normally go like this. Oh, not like that. I normally go something like that. I reflected over the x-axis. So this is no good. It now does something like this. Okay, and then I went to the right 4. 1, 2, 3, 4, and then I went, and then I went down 3. 1, 2, 3. Okay, so let's get rid of this mess right here. And it's going to do something like, we're going to have an asymptote at x equals 4. And we're going to do something like this. Okay, so our pivot point is now the point 5, negative 3. It should be the exact, notice, we had negative 3, 5. We've switched our x and our y, and there we go. Our asymptote before had been y equals 4. It's now x equals 4. Our end behavior, we could say as x goes to infinity, our y value is going to go to negative infinity. Okay, a second ago, we had as x goes to negative infinity, y goes to infinity. So we have taken this part right here and switched our x and our y's. And then we have as, I guess we could say as x goes to 4, y goes to infinity. And that's kind of switched the x and y's at this point. The domain is from 4 to infinity. The range is all reals. Okay, once again, if we want to find the pivot point without just counting on that graph, what we want is we want this part right here to equal 1. Okay, so if I can say x minus 4 equals 1, I know that that's when x is equal to 5. So what I'm really looking for is what happens when I plug in 5, negative log base 2 of 5 minus 4 minus 3 would be equal to negative log of 1. Well, minus 3. We know that log of 1 is equal to 0. This is 0 minus 3, and that's where we got that, well, 0 minus 3. That got a little sloppy. 0 minus 3 is negative 3, and that's where we got this value right here. Okay, it's almost my lunchtime. I'm going to make another video for these right here, so go check that out when it's done. So hopefully that wasn't too confusing. Let me know if you have questions.